6.3 is about square root functions. So the most basic square root function is y equals radical x, or f of x equals radical x. Let's start by talking about the domain and range. The domain of a square root function is, well, the only rule is that the radicand has to be positive or 0. So the radicand has to be greater than or equal to 0. The radicand is not allowed to be negative. So the domain is x is greater than or equal to 0. The range is y is greater than or equal to 0. And the reason for that is when you take the square root of something, it'll either be positive or it'll be 0. We're not doing imaginary numbers here. So if you plug in a positive x value, which that's what we have in our domain, if you plug in a positive x value, that's what it says there, you will get a positive y value. Or I should say non-negative. If you plug in a non-negative x value, you will get a non-negative value for the square root. All right, the intercepts. The x-intercept is 0, and the y-intercept is 0. The parent graph goes through the origin at 0, 0. All right, so I think the easiest way to graph this would be to make a table. So instead of writing x comma y, or x in one column and y in the other column, I'm just going to put what y equals. So my table is going to be x and then radical x, which is y. All right, if you plug in 0, the square root of 0 is 0. So let's plot that point. If you plug in 1, the square root of 1 is 1. Now, 2 is not a good number to plug in. Let me plot 1, 1 first. 2 is not a good number to plug in because 2 is not a perfect square. So the next number I'm going to plug in is 4. Square root of 4 is 2. And we don't do plus or minus because we're not solving, we're merely simplifying. So now I'm going to graph 4, 2. 4, 2. All right, if my graph was bigger, the next number I would plug in for x is not 5 or 6 or 7 or 8 because those are not perfect squares. I would plug in 9 next. So you want to plug in values where if you take the square root, you're able to do that mentally. So 9, 3. So the graph looks like this. So it's basically a sideways parabola, but only the top half of it. So think of the parabola y equals x squared. If we turn that sideways, but then we chop off the bottom half, that would be what we have here. All right, so now we're going to transform square root functions. All right, I won't write these down because we've learned them before. We know that the h value that I'm highlighting, that will shift the graph either to the left or to the right. If you see subtraction, it'll move it to the right. And if you see addition, that'll shift it to the left. Those are called translations. And then the k value is also a translation. That shifts the graph up or down. Addition is up, subtraction is down. All right, we learned that if you have a number in front here, well, first of all, if there's a negative on that number, that will reflect it across the x. And then if a is bigger than 1, it'll be vertically stretched. And if a is smaller than 1, it'll be vertically compressed. All right, and then finally with the b value, if you put a negative in there, it reflects it across the y-axis. So if there's a negative inside the radical, the graph gets reflected across the y-axis. And then the absolute value of b tells you which way it stretches or gets compressed. If absolute value of b is bigger than 1, then it's horizontally compressed. Absolute value of b smaller than 1, then it's horizontally stretched. So it's kind of backwards. Bigger than 1, compressed. Smaller than 1, stretched. And that's for the b value, and it's horizontal. All right, but we're not going to make you describe the transformations in this section. It's just so you know what the graph will look like. Now, I actually just recommend making a table. Then you don't really have to think about the transformations. You could just graph the points in your table. So I want to start number 1 by doing the domain and range. So for the domain, recall that whatever is under the radical has to be greater than or equal to 0. Then you solve that, divide both sides by 2, and you get x is greater than or equal to 0. So that is our domain. Our domain is x is greater than or equal to 0. All right, our range. So your range is going to be y is greater than or equal to 0. The only times that would change if there's a negative in front of the radical, that would flip it around. That would flip the inequality around. And also, if there's a k value. If there's a k value, that would shift the range up or down to a different number. I'll show you guys when we get to an example like that. So those are our domain and range. Now let's make a table. And so I like to do 3-column tables. And I'm going to make a 3rd column to the left. Now that we're not going to graph that column. So let me highlight. These will be the points that we're going to be graphing, x comma y. However, we want to choose nice x values based on the radicand 2x. So we want 2x to be a perfect square. So we want 2x to be numbers like 0, 1, 4, 9. So what value of x would make 2x equal 0? Well, that would be 0. What value of x makes 2x equal 1? That would be 1/2. So I'm just deciding what x values would make 2x equal a perfect square. So if x was 2, then 2x would be 4. If x was 9 over 2, then 2x would be 9. So these are the nice x values. And now I'm just going to square root 2x. And the easiest way to square root 2x, we already have these values that I'm boxing in green. We already have those values of 2x. I'm just going to square root those numbers now. So if I square root 0, I get 0. If I square root 1, I get 1. Square root of 4 is 2. Square root of 9 is 3. So remember, you're not graphing the first column. So I'm just going to cross these out so I don't accidentally graph them. All right, so first point I want to graph is 0, 0. Then I want to graph 1/2, 1. 2, 2. 4.5, 3. And if we kept going, I don't think it would fit on the graph, but let's say we kept going. So we had a 16 here, which would make this an 8, and then this would be a 4. Does 8 comma 4 fit on the graph? It would just be barely off the graph, so we could kind of aim for that. All right, I think we would benefit from some more practice. Okay, I'll do the domain and the range last. So first thing I want to do is make my 3-column table. I want the radicand is my first column, x is my second column, and y is my third column. So we want the thing under the radical to be a perfect square, so we don't need a calculator. We want that to be a perfect square. So we want x over 2 to equal a nice number like 0, 1, 4, or 9. And then now we figure out what values of x would make that. And so basically, this says x divided by 2, so I'm going to do the opposite and multiply the numbers I just wrote by 2. So 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. And now, this is not going to fit on the graph. 9 times 2 is 18. So those values of x would make it so that we could figure out what y is without needing a calculator and without needing any decimals. And so now I want to take negative and then the square root of these numbers. Negative and then the square root of those numbers. So the negative square root of those are 0, negative 1. Let me write these down. 0, negative 1, negative 2, negative 3. I'm taking the negative square root of the first column. All right, so remember, you are only graphing these 2 columns on the right. So we're only graphing these points, not graphing that. Okay, so 0, 0. Then notice this one goes down. 2, negative 1. The reason it goes down, there's a negative in front of the radical. 8, negative 2. Does that fit? Just barely. 8, negative 2 is down here. So it's like a upside down square root. And we still have to do the domain and the range. So another technique you could use for the domain and range, you could just take, if you use my table method, these are going to be the numbers for the domain and range. Now you just have to figure out which way the inequality is going. So our x's seem like they stay above 0. However, our y's stay below 0 because it goes upside down. So there's our domain and range. On the back, we have 2 more equations, and then we're going to do 3 inequalities. So I'll start by making my table. 3 columns, x minus 3, then x, and then whatever y is. So in this case, y is 2 times radical x minus 3. All right, so again, we want the radicand to be a nice number, like 0, 1, 4, 9, and I don't think 16 will fit. Okay, now what x values would make x minus 3 equal those? Well, we do the opposite. Since that says x minus 3, we're just going to add 3. So add 3 to 1, add 3 to 4, and add 3 to 9. So I added 3 to all of the numbers in the first column. Those tell me the nice x values that'll make our radicand a nice or a perfect square. Okay, so now I want to take the first column and square root it. I want to take the first column and square root it and multiply by 2. So take the first column, square root it, and then double it. We end up with 0. 0 for the first number. Then we get the square root of 1 is 1, and then we double it. The square root of 4 is 2, and then we double that. The square root of 9 is 3, and we double that. So now we're going to graph just these points. First point is 3, 0. Next point is 4, 2. Then 7, 4. And 9, 6 won't fit. Our domain. So first point from your table will be the numbers in the domain and range, and you just have to figure out which way the inequality points. Our x's stay above 3, and our range looks like the y stays above or equal to 0. Okay, I'm going to make my table for number 4. I start with the radicand, then the x, and then the y, or what the y equals. We want the radicand to be a perfect square. So the radicand will be a number like 0, 1, 4, 9. I'll add more if I need to later. So then you're going to add 3 and divide by 2. Add 3 and divide by 2. This would be 3 over 2. So you're doing the opposite of what you see here. Add 3 and divide by 2. So 1 plus 3 is 4. 4 divided by 2 is 2. Take 4 and add 3. That's 7 divided by 2. Take 9, add 3. That's 12. And divide by 2 is 6. So those values, if you check, those values will make our radicand a perfect square. So now for the y column, we're gonna take the right column. We're gonna square root these numbers and then put a negative sign on it. So you're gonna square root and multiply by -1, 0, -1, -2, -3. Okay, graphing just these points. And let's check. Can we fit one more point on here? So if this was 16, this would be 19 over 2, and this would be -4. I don't think that fits. Okay, so now I'm going to finally graph the points. 3 over 2 is 1.5, so 1.5, 0 is here, 2, -1, 3.5, -2, 6, -3, and that last point, 9.5, -4, does not fit. So make sure you don't put an arrow on the starting point. Only put an arrow on the other end. These are not lines where they go infinitely both directions. Okay, we use these numbers for our domain and range. Domain looks like our x is all stay to the right of 3 over 2, but this one's upside down, so our range, y stays below or equal to 0. Okay, for inequalities, looks like we have 2 number 4s. For inequalities, I'm going to start with my 3-column table. So I have 2x, x, and then whatever y is. So y in this case is radical 2x. We want nice numbers like 0, 1, 4, and 9. Divide those numbers by 2, you get 0, 1/2, 2, and we'll do decimal, 4.5. Let's see, if we include one more, 16, I don't think that'll fit on the graph. No, it'll just be barely off the graph. All right, so we want to take the square root of 2x. So the square root of the first column, 0, 1, 2, 3, 4. And then we are graphing just these points. All right, so 0, 0 is at the origin. 1/2, 1, 2, 2, 4.5, 3, and 8, 4 doesn't fit. All right, so now the only difference, do you need a solid or dashed line? You have to determine that because it's an inequality. We want a dashed line or curve for this one. So I draw it dashed. And then now I have to figure out where to shade. Now be careful with your shading. We want to be below this graph. However, we don't want to go outside of the domain. So don't go to the left. Don't go to the left because those points, they don't exist. So only stay underneath. All right, and we don't do domain and range for inequalities. All right, for number 5, I'm going to set up my table, 2x minus 3, x, then what does y equal? It equals 2 times radical 2x minus 3. We want nice numbers here, 0, 1, 4, 9. We need to figure out what x's would make 2x minus 3 a perfect square. So to figure that out, I'm going to take the first column, add 3, and divide by 2. So this would be 3 over 2. Add 3 and divide by 2. 1 plus 3 is 4, divide by 2 is 2. Take 4, add 3, and divide by 2. These numbers look pretty familiar. Take 9, add 3 is 12, divide by 2 is 6. All right, so what are we doing to the left column? We're taking the square root and multiplying by 2. We're taking the square root of that and then multiplying that value by 2. So square root of 0 is 0. Multiply that by 2, still 0. Square root of 1 is 1, and double that, you get 2. Square root of 4 is 2, double that, you get 4. You guys might see a pattern. This one would be 6. All right, do we need to include one more? If we did that, 16. This would be 19 over 2. Don't think this fits. This would be 8. All right, graph these points here. So we have 1.5, 0. We have 2, 2, 3.5, 4, 6, 6, and that's all that fits. All right, on this one, we want a solid line. And we want a shade above. Now keep in mind, do not go to the left of the first point. So we're shading over here. Don't go to the left. So strictly stay above the very first point. Okay, one more. Make the table. Last column is just whatever y is. Want this to be a perfect square. How do I figure out what value of x makes 2x minus 1 equals 0? I basically add 1 and divide by 2. So add 1 and divide by 2. Add 1, you get 2. Divided by 2 brings it back to 1. Add 1, you get 5, and divide that by 2. Add 1, you get 10, and you divide that by 2. All right, let's check one more. Add 1, you get 17. 17 divided by 2 is 8.5. That'll just be a little off the graph. All right, so what are we doing to 2x minus 1? We are taking the square root, multiplying by 2, and subtracting 4. So for the last column, take the first column, take the square root, multiply by 2, and subtract 4. So 0 multiplied by 2 is 0, minus 4. Square root of 1 is 1, multiply that by 2, and subtract 4. All right, you guys, if you do my method, you could actually see a pattern. These are just going to go up. After you do the first 2 points, you should realize they're just going up by 2. And you can double check if you want. All right, graph only these 2 columns. We have 1/2 comma negative 4. We have 1, negative 2, 2.50, 5, 2, and 8.54, which doesn't fit. We want a dashed line on this one. And we want to shade below. And that's it for 6.3.